Compare the domain range and any existing intercepts of the functions f of x equals negative x plus 2 squared minus 1 and g of x equals negative square root of x plus 2 minus 1. Write domain and range as inequalities. First, let's do the domain of f of x. Since f of x is a parabola, it goes on forever in both directions. And so that's just from negative infinity to positive infinity. We can write that as negative infinity is less than x is less than positive infinity. And we don't use an equal to sign as well because infinity is not a set value. All right, range of f of x. So for this, we need to know our values a and d in the function. A is just the number in front of the parentheses. Since there's nothing in front other than a negative, that's the same thing as a 1. So we have negative 1 for a, and then d is just the number in back with its sign. So a is important because it tells us that if it's negative, so if it's less than 0, we know that our parabola will face downward. And that's important to know the direction there. And then D tells us basically whether it's a maximum or a min. And so negative 1 is actually our maximum here. And so now we know that f of x is going to start at negative 1 and get smaller. So we can write that as less than or equal to negative 1. Going on to the domain of g of x, we need to also know the values of b and c for domain of g of x. And then for the range, we're going to need to know a and d. So let's just go ahead and point out all the variables in this equation. So a is the number in the very front of the square root. So again, it's going to be negative 1 right here. So a equals negative 1. B is the number in front of x. And since there's nothing there, it's just a 1. So b equals 1. C is the number after x, but the key here is that in standard form, it's x minus c. So because of that, then, or it's bx minus c, but so it's x minus c, and it's a positive here. So that's the same thing as saying x minus negative 2. So because that's positive, you basically need to switch the sign and say c equals negative 2. And then the last one, d equals negative 1, the number with the sign. So for the domain, since b is 1, it's greater than 0, and that just tells us that in the square root function, it's going to have a starting point and then it's going to get bigger. That's what b tells us. And then c tells us the starting point. So actually b and c, excuse me, tell us the starting point. And so it's actually going to be c divided by b. So since c is negative 2, that divided by 1 is negative 2. And that's our starting point, and then it's going to get greater. So the way that we write that is x is greater than or equal to negative 2. I'll just box that. And now going to the range of g of x, we know a is negative 1, and so that means it's less than 0, and that tells us that in our graph it flips over the y-axis. And then d is negative 1, and that tells us, again, it's going to be a maximum like before in our parabola, and so that's the highest it ever goes. So the way that we'd write that is g of x, and it's a maximum, so it's going to get smaller, less than or equal to the starting point, which was negative 1, our d value. So notice here that the range f of x and the range of g of x are the same, and then the domains are different just because the domain of a square root function is going to be restricted. All right, so now we're going to look at the y-intercept of f of x, g of x, and then the x-intercepts of both. All right, so for the y-intercept of f of x, I'm going to go ahead and switch pens so that we can see this a little bit better. So the y-intercept, we know that with y-intercept, x equals 0. So let's go ahead and plug in 0 for our function, f of 0, and just plug it on in for x. So we have negative, parentheses 0 plus 2 squared minus 1. So 0 plus 2 is just 2. So we have negative 2 squared minus 1. Make sure to do parentheses and the exponent first. And then you put the negative on. So 2 squared is 4. So that's negative 4 minus 1. Negative 4 minus 1 is negative 5. So our y-intercept is going to have x as 0 and y as negative 5. Looking at the y-intercept of g of x, do the same thing. You just plug in 0 for x. So we have negative 0 plus 2 minus 1. So it's negative square root of 0 plus 2 is just 0 plus 2 is just 2, then minus 1. In standard form in math, we just put the number first and then the square root. So that is our y value. So we have 0, negative 1 minus square root of 2. All right, and that's parentheses. Okay, so x-intercept of f(x) and g of x. Here we need to look at the a and d values. So in both cases, a and d are negative, negative 1, negative 1, and negative 1, negative 1. Because of that, that basically tells us that both are below the x-axis, and they actually never touch the x-axis if they're both negative. So therefore, there are no x-intercepts. Now we need to compare also the x-intercepts and y-intercepts. We see that the y-intercepts are different, and they both don't have x-intercepts. So we can go ahead and summarize all of our conclusions here. We see that the domain of the quadratic function f of x is negative infinity is less than x is less than infinity. The domain of the square root function g of x does not contain all real numbers like the domain of f of x, but rather is restricted to x is greater than or equal to negative 2. Despite the identical parameter values of f of x and g of x, their domains are quite different. The range of f of x is f of x is less than or equal to negative 1. The range of g of x is g of x is less than or equal to negative 1. The ranges of the functions are the same because their parameters are both negative, and the value of the parameter d is negative 1 for both functions. The y-intercept of f of x is 0, negative 5. The y-intercept of g of x is 0, negative 1 minus square root of 2. Despite the identical parameter values of f of x and g of x, their y-intercepts are quite different because the functions are different types of functions. Neither f of x nor g of x has an x-intercept since their parameters a and d have the same sign.